Here we would like to use piecewise functions to find the given limit. So here we're going to use this piecewise function defined as x to the third when x is less than 3 and 3x is if x is greater than or equal to 3. First we're finding the right-sided limit, namely when x approaches 3 from the right, the limit value of the function. So x approaches 3 from the right, meaning that we're going to start with the x values larger than 3. Larger than 3 will be for this function here. Okay? Notice a piecewise function consists of usually at least two different functions based on the x ranges. So here, when x is less than 3, we're going to be using one function. When x is greater than or equal to 3, we're going to be using this function. When we're talking about the right-sided limit, we're talking about x values greater than 3. That's why we need to choose this one, because x is greater than or equal to 3. So we need to use this 3x when we're trying to find the function value as x approaches 3 from the right. So 3 will be multiplied by the target value of 3 here, because that's where the x value approaches from the right side. 3 times 3 is 9, right? So the limit here is 9. And notice this is only the right-sided limit that we just calculated. Now here we need to find the left-sided limit because x approaches 3 from the left, meaning that we're going to be starting from the x value smaller than 3. Now smaller than 3 is going to be determined by this constraint, x is less than 3. Thus we need to use x to the third when we're trying to evaluate the limit. So we're going to be plugging in the target value for the x, 3, in here into this x. So 3 to the thirds is precisely 27. And this is the left-sided limit for the function. This is the left-sided limit of the function as x approaches 3. Okay, from the left. Now, finally, the overall limit, as you can see, it only exists when both-sided limits agree. If the right-sided limit and the left-sided limit have the same value, then the overall limit will exist. As you can see, these values are different. The right-sided limit is 9, whereas the left-sided limit is 27. So overall limit does not exist. Now in the next example, this is going to be pretty much the same, except that they're tweaking the top function. The top piecewise function, they're revising. Instead of x to the third, they're writing it as x to the third minus 18. And why are they doing that? Let's see. So we're going to be using the same function for the right-sided limit, because obviously that didn't change, right? So it's 3 times 3, that's the target value of the x, is equal to 9. That doesn't change. However, for the left-sided limit, we're going to be using the tweaked top piecewise function, x to the third minus 18, instead of x to the third. So we're going to be plugging in 3 into this x to the third minus 18. So that's going to be 27, as it was before, minus 18 this time. 27 minus 18 is 9. And what does that change? That makes a crucial difference that they revised this top piecewise function, because now both the left-sided and the right-sided limits agree, right? They're the same value. Whenever they agree, that will be the value automatically for the overall limit. So the overall limit as x approaches 3 of the function is going to be 9. So I hope this was helpful. Thanks for watching. See you in the next video.